is greater than x, okay, because 11 times. All right, so let's go all the way back to the content of the lecture, or the content of this class. So we go to courses, go back to this class. And where we are at this point is top-down design. And we are pretty much done with top-down design. The only thing left is, okay, so now we got two pieces of code. One piece of code focuses on finding all the prime factors of a number, not just one, okay? The other piece of code just finds one prime factor given a particular number. So how do we combine those two? Well, we can just copy and paste one and put it inside the other one, okay? So for the time being, that's the only mechanism that we have. But later on, when we talk about subroutines or functions, then we'll find out that, oh, there are better ways to do it. But for the time being, that's what we're going to do. So let me just kind of click on this link here, just so that we know where we are in terms of the notes. And this is the wrong class. It keeps opening the new tab somewhere else. And there we go. So when we talk about top-down design, we have just talked about how to find a prime factor. So that's 3.3.4. So moving on to 3.3.5, the question is whether we put it inside the code or not. So if we want to put it inside the code, this is the finished product, where the lines from 3 to 6, this one does not use the faster mechanism to get out, so this is kind of like the more time-consuming version. But nonetheless, from line 3 to line 6 is the code to find a prime factor given n, and then the overall code is to find all the prime factors given a particular n. Is that okay? Yes? So we are putting one chunk of code, which is this chunk here from line 3 to 6, into the other chunk of code, which is from lines 1, 2, and then 7, 8, and 9. Is that okay? So the integrated version shows all the details of how to factor a number. Now it becomes harder to read because we are making this code longer. So later on, when we talk about subroutines, we'll start to say, okay, is there a better way to collapse line 3 to line 6 into a single line so that we just describe what those lines are doing as one single line? Okay, but we are not quite there yet. Okay, we'll talk about subroutines a little bit later in the semester. The top-down design, of this entire thing is we start with something that's simple. Okay, so let me go back to this part here. So this is the overall code where line 3, says find a prime factor f of n. That's all it says. Does it tell us how to do it? It tells us what it is supposed to do, but does it tell us how to do it? The answer is no. It doesn't quite tell us how it is done. It is just saying, well, somebody needs to find me a prime factor f of n, but once I have that f, then I can perform the following, which is printing f to the screen so the end user can see it, and then we also divide n by f so that n itself is now reduced, and we keep doing this until n becomes 1, then we are all done. Okay? So that's what we have talked about so far about top-down design. Section 4 is here because there will be professors telling you that top-down design is the only way to write a program. You have to be able to design a program using the top-down method from start to finish. Okay? Now, I have worked in industry, and I can tell you it is not possible. Okay? So in theory, yeah, that is nice, but in practice, it is not possible. So when you are actually writing programs in CISP 360, 400, 430, and so on, you'll be writing some parts of the program in a top-down fashion, but you'll also be writing some code from a bottom-up fashion. Bottom-up is exactly the opposite of top-down. Okay? You can call it the quote unquote grassroots version of coding. Okay, you start from the details and then you work your way up. Okay, so why would I want to write a program from the bottom up when we are supposed to use the top-down design because we can only keep track of 5 to 10 things at a time? Bottom up is easier to debug because you start with 3 to 9 lines of code that is relatively easy to debug. Okay, you work on those. You work on that logic, that particular algorithm. You test it. You prove that it works correctly, and then what do? You turn that into one unit. Okay, and then you say, okay, given these larger building blocks, what can I build now? So now you have a bigger building block. You can now start to build even larger objects. Now, given those objects, which are now larger, you can now build even larger and larger objects. Is that okay? So that's the bottom-up approach. In practice, in industry, there are many times when people need to use bottom-up. It is particularly good for debugging purposes. It's just not good from the perspective of if you start with a very complex project, you have to use the top-down approach to get to like manageable sizes. But once you get to the manageable sizes, then you can use the bottom-up approach to actually do the coding. So there are many phases to writing a program or developing a system. A part of it, we can use top-down. The other part, we want to use bottom-up. Okay. Now, as a part of this class, we are also supposed to talk about the software development life cycle. Okay, how many people have encountered that term? Sdlc, software development life cycle. Okay, so I'll give you an example. So let's just say that you're working for Wells Fargo IT. Okay, say they need to build a brand new system. Okay, so that people can look at their finances, more easily, and everything is in real time. And they can even give feedback to customers, as in, well, I think you might want to, save some money over here or put your money over here for investment, blah, 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 okay? Obviously, that's going to be a huge IT project, a huge information technology project. So the question now is, how do you go about implementing that particular IT system, information technology system? Okay. 2 approaches. One is you plan every single detail out first, and then you carry out that plan. 2 is, well, we'll just go ahead and do something, release it, and then we'll refine it. Okay? So which way do you think is better? The first or the second? Okay, so I got some first and I got some second. Okay? And you are both right. It depends on what is important. If you are looking from the perspective of security, if you're looking from the perspective of, we don't want the system to make mistakes, it's better off to plan everything out first. Okay? But on the other hand, if you're thinking from the perspective of, I know Bank of America and Chase are trying to do the same thing, then the second approach may be better. In other words, the second method, by the way, is called the Agile framework. The first one is called the Waterfall Framework. So the Waterfall Framework, as the name implies, has steps. Okay? So you go through the first step of planning, and then you go to the second stage, you go to the third stage, you go to the fourth stage, you go to the fifth stage, and you never go back. Okay? And the idea is it will take a long time, but by the time you get to the last stage, you have every detail already planned out, and it will be like an impeccable plan. Okay? The other approach is called Agile. Okay? If you just look up Agile in terms of software development lifecycle, it's basically just saying, okay, we'll try to get something out the door as soon as possible. Okay? When we get something out the door, we'll keep refining it, we'll keep adding features, we'll keep fixing bugs and whatnot, but it's a continuous process. And the cycle itself is relatively short. Using the waterfall life cycle, you can be looking into years. Okay? From the first stage to the last stage, that can be years in between. When you're looking into Agile, okay, you're talking about at the most months. So the two development models are very different. One is what people used in the past, and it is really still used for critical systems. The second one is used for things that have where timeliness is a big deal. Okay, think about TurboTax. If you try to use the waterfall approach with TurboTax, what's going to happen? You will never release a product. Why? Why do you think that is the case? Let's just say that it takes 2 years to go through one entire waterfall, approach. What's going to happen in a year in terms of taxes? Tax laws changes every year. So that means halfway through this whole thing, tax laws changes again. Now you have to invalidate what you have done and go back to the first step. You will never release a product. Is that making any sense? Okay. Now, when you look at all the mobile apps, okay, I know you guys got apps on your mobile devices, right? Okay. Which approach do you think is better for mobile apps? Agile. Because otherwise, you have an idea and you say, okay, but I'll carefully plan out every detail first before I implement the system, before I release it. You will encounter two main problems. The first problem you will encounter is your competition. Okay? Somebody's going to release something that is competitive to yours with some bugs, but they will get to the market, and which means they will gain market share. It may be buggy, but guess what? The product of the name of your product is not even visible to people yet. Okay, that's one problem. The second problem is, does anyone have any idea of how many updates you will get when it comes to development tools for Android? Okay, I'll give you a few numbers. Once a year, twice a year, once a month, once a week. Once a week, yes. So if you get everything so carefully planned out, by the time you implement, those features have changed. You're already 2 versions of Android behind from the time that you started your planning. Would that be helpful to your mobile app? No, because your app is going to look really ancient and out of date. So do you guys see why the waterfall approach, even though it has a lot of appeals, sometimes it doesn't work. And then the agile approach is what people are doing these days, is using the agile approach, which is basically saying everything is continuous. It's a quick cycle. We deliver something while we are still working on it. We'll deliver whatever we can that serves a purpose to the client, while at the same time keep working on it. So, so the whole idea of that is really just to talk about top-down and versus bottom-up. In most cases, is a combination of the two. All right. So let's go back to our notes here. So at this point, we are going to transition to talk about arrays, which basically means by this time, you really need to know about variables, assignment statements, conditional statements, the 2 kinds of loops. Okay, so all of those control structures, you really need to have a good understanding already. Now we're going to move into arrays. And where did it put it? Here. Okay. So this is a new module. Okay, it's a new concept. It's basically a brand new concept. But what we'll do is we're going to start with something that you know already. Okay, so we'll start with this slide here. Without reading the comments on the description, does anyone recognize this code here? What does it do? Trying to find the maximum. Again, I mean, come on. We have looked at this code so many times already. But it is useful, okay? It's something that we already know, so it is really useful as an example to illustrate a point. So in this case, we are trying to find the maximum of how many variables? There are 2, right? Between A and B, I want to find the maximum, and the maximum is stored in variable m in this case. Okay? We know how to do that, not a problem. What about here? What do you think this code is doing? Okay, so we may not have seen exactly the same logic as before, but let's try to follow the logic here and try to figure out what it is doing. What is this doing here? It's AND. Very good. Okay. So if A is greater than or equal to B and A is greater than or equal to C, then M gets A. What do you think A is in this case? If I do end up on line 2, what is A relative to B and C? It's the maximum. Very good. So now we have a pretty strong suspicion that this is once again, guess what? Finding the maximum of, in this case, 3 variables, right? But let's read on and confirm that. Else, okay? How can I end up on line 4? In other words, what is the precondition of line 4? A is less than B or A is less than C. Okay, so you negate when you put a negation, you quote unquote distribute the negation using what we call the De Morgan's law, but then you have to change the operator to a or. Okay, so we know that A is less than B or A is less than C, but it tells us that A is not the maximum, right? If A is less than C or A is less than B, that means A cannot be the maximum. Is that making any sense? Okay. So knowing that A is not the maximum, line 4 says if B is greater than or equal to A and B is greater than or equal to C, then M gets B. If I want to find the maximum, does that make sense to you? Yeah, okay. Does it make sense to you that this else, without any asking any additional questions, it would just say that if I get to line 7, C has got to be the maximum. Does that make sense to you? Okay, very good. So this code finds the largest or the maximum of the three variables, A, B, and C. Is that okay? Do you guys feel comfortable using this approach to come up with the pseudocode to find the maximum of 4 variables? Okay, if I give you variables A, B, C, and D, and I ask, okay, write the pseudocode to find the maximum of A, B, C, and D, do you feel comfortable that you kind of know a systematic way to do it? I think most of you will say, yeah, we can just say if A is greater than or equal to B, and A is greater than or equal to C, and A is greater than or equal to D, then A is the maximum, right? Else, A is not the maximum anymore. Let's try B. If that doesn't work, try C. If that doesn't work, then D has got to be the maximum. So I think we have a general idea of how to extend the logic to handle more and more and more variables. Is that okay? This class has approximately 50 students. What if I want you to come up with a pseudocode to find the maximum of 50 variables? That is a lot of code, exactly. Because your conjunction, guess what, has now 49 terms, because you have 50 variables. So to confirm that one is the largest or the maximum, you need to compare that variable to all the other 49 variables. So first of all, it takes a while to type it, okay? And I'm pretty sure most of you do not want to spend your time just typing, right? But it's not just horizontally long, it's also vertically long, right? Because we end up with how many of these lines, like line 2, line 5, line 7, and so on? We have exactly 50, right? Because we have 50 variables, and each one can be the maximum. So we have 50 branches. Not to mention that there are a whole bunch of if, else, and if, and whatnot. Okay? This approach does not seem to be a very efficient way of working that out, does it? Okay, so that's why we need arrays, okay? So I'm going to show you what the array solution looks like, and then we'll go back and explain the concepts of an array. This is what the array version of the code would look like, and it can handle any number of variables. In other words, you can give me 10 variables, it looks like this. You can give me 100, it looks like this. If you give me 1,000, it looks like this. If you give me 1,000,000, it looks just like that. Now, The code looking simple doesn't mean that it will take a short amount of time to finish, but nonetheless, the idea is we only have 8 lines of code, regardless of how many variables we are trying to work with, in other words, finding the maximum out of. That seems to be a winner compared to what we have been doing before. Yes? Okay? So this is the rationale. This is the rationale of why we need to understand arrays, because it is capable of expressing algorithms with arrays as a concept. Then we can express algorithms that are much more efficient when it comes to handling, a large number of items. So are we good so far with the rationale of why we need to talk about arrays? Okay, excellent. All right. So now we need to talk about the actual notation and the concepts and whatnot. So we're moving on to section 3. So section 3 is simply asking, what exactly is an array? How do we describe an array? The first thing is an array can be seen as one variable. Okay, so that seems kind of awkward because an array has things inside, but sometimes we can look at it as one single variable. How does that work? Okay. When was the last time you ordered more than 1 items from Amazon and it comes in a box? Yesterday, today, when you get home, you'll have a box, right? I mean, these days we order things from Amazon all the time. So when the courier, drop off a box that inside may have like 6 items that you order from Amazon, to the courier is 1 item. But when you open up the box and you go, oh, okay, I'm just double checking that I got all 6 items in the box. Now you have 6 items that were inside the box. Is that okay? So what an array is, it is a container. The container can have items inside of it. The other thing you can also look at an array as, not as good as an analogy, is a folder. Okay? These are the 600 pictures that I took yesterday of my nephew's soccer game. Okay? But you put everything into a folder, right? So when your aunt says, oh, I need pictures of that guy, in the soccer game, are you going to move like 600 things over, or are you just moving the folder? Oh, it depends. I mean, some people feel better when they have to move like 600 items, but I'm moving the folder. I'll just click on the folder, Control-C, move on to the other folder, Control-V, done. Does it make sense? So this is why we look at an array as one variable sometimes. Okay? When it is appropriate, we look at the entire container as if it is just one thing. Other times, we have to look into the container and say, okay, we got 6 items inside the container. Which one do you want to access? So there are times when we look at the entire thing as a box, and other times we look into each individual item inside the box. Are we good so far? Okay. All right. So we got some fancy terms here. Element. Okay. What do you mean by an element? What is an element in an array? Fancy words. An element is a thing inside an array, which is a box. So each thing inside the box is called an element. That's it. They all must have the same type. Now, we're going to defer the discussion of types until much later. So for the most part, we can ignore that qualifications for now. Okay? Each element has an index, which is a number. What do you mean by that? Well, if you have a box with several items, how are you going to differentiate one item from the other item? With an index, okay, which is a number. So what we do is we open the box, okay, and say, well, there are 6 items in here. Which one do you want? I want the one that is labeled 2. And there should be only one item that is labeled 2. Because the 6 items inside the box should be labeled 0, 1, 2, 3, 4, 5. Okay, we always count from 0 in computer science. Is that okay? So the index is referring to a unique number of each item inside a box. It starts with 0, and it just goes sequentially up to n minus 1, where n is the number of items. Can someone explain to me why it only goes up to n minus 1 and not n? Because we start from 0. Very good. All right. Well, that's what the next sentence says. Okay, fine. Moving on. Indexes of elements must be contiguous. 0, 1, 2. You cannot skip numbers. You cannot say, okay, we got 15 items, but I don't like the number 13. Can we skip the number 13? The answer is no. Okay? They have to be contiguous. Next one. If A is an array, then I use the bar A bar notation to tell us how many items are inside array A. In other words, it is basically telling you how many things are inside a box. The box itself has the name of A, and then bar A bar is saying, okay, how many things are inside the box? Huh? Just like I borrowed the notation of an absolute value, but it doesn't mean absolute value. I'm just borrowing the notation. Okay. The next one, the last item in an array has an index of bar A bar minus 1. Does that make sense, given how we define bar A bar? Bar A bar is the number of items inside the box, but since we start labeling the items using 0, so the last item in the box has bar A bar minus 1 as its index. Let's say there are 6 items in a box. The first item is labeled 0. The next one is 1, 2, 3, 4. 5 is the last item of the box. It's the index of the last item in the box.
So 5 is the last one in the box. Could you say plus 1 instead of minus 1, so it would be 6 because you started with 0?
Well, 5 itself is 6 minus 1. 6 is bar A bar in this case.
Oh, so you subtracted
I subtract the number of items in the box by 1 to get the index of the last item. Okay? And the last point here is a special notation, which is A open bracket I close bracket. What it means is, look at box A. Okay, here's a box. I want you to focus on a particular item. Which item? The item that has an index of I in this case. Okay? Which is kind of nice because you can look at the square bracket as a box. A is outside of the box, so A is the name of the box. I is inside the box. It is trying to identify a particular item inside the box. So that's one thing you can try to, it's kind of pictorial, so you can use this notation to kind of remember that A refers to the box itself, and I refers to the index of the item inside the box. Are we okay so far with all of these concepts? Okay? All right. So just to make sure that we have a kind of a visual way of looking at this, let's go to Zerno, if I have one already. And I may not have, oh, I got one. There we go. But I don't know where it is. Okay, let's move it to where we are. There we go. Okay, I'm going to keep this one around, and I will talk about it a little bit later. So I'm going to open a new one. Okay. There we go. So what I want to do is really just to draw some pictures, just so that some of you who are more visual in terms of learning can associate the concept with a picture. So let's say we have an array of A. So an array is a box. So when I say array A, it means A is the name of the box, so I can differentiate this box from other boxes. And let's say A only has 3 items inside, okay? So these are the 3 items inside A. So now the question is, how do I differentiate these containers inside a box? Coffee mugs, glasses, or whatever you want to call these. It is the index number, okay? And the index is always a number, starting with 0, 1, and 2. Is that okay? Yep.
The index was I, the last example?
Well, I is just a placeholder for the index. Yep. So if I say, A bracket 1 in this case, what am I referring to? The A is talking about the name of the box. So if I just say A, I'm referring to the entire box, okay? But if I use the square bracket notation, I'm saying, no, I don't need the entire box. I just need one item inside the box. So inside the square bracket, I need to spell out, okay, which item do you want? I want the item that has an index of 1 in this case. So that means this notation is referring to only this item. Only one item out of the box. Is that okay? Yep.
What would the A with the absolute value sign look like?
Okay, so bar A bar, what do you think bar A bar is in this case? Bar A bar is always going to tell you the number of items in the box. So what do you think it is in this case? 3. That's right. So are we good so far with the concept of an array? Okay. It is important to remember that every item inside a box has an index, and the index is always a number, and those numbers always start with 0, and they're always contiguous. Okay. So now the question is, okay, so what is the big deal? I mean, well, each item in this case inside a box can be seen as a variable as well, because each one individually can store some information. They can store some data. Is that okay? All right. So let's go ahead and look into an algorithm to initialize an array with some particular values. Okay. And we'll look for this guy. Okay. Get rid of all of that stuff. So the algorithm, let's say we are dealing with a box with only 3 items, okay? So we can say A bracket 0 gets 0, A bracket 1 gets 0, A bracket 2 gets 0, 2. So what this is doing is initializing the entire array with 3 items, and every single item has a value of 0. Is that okay?
Yep.
All right, cool. Doesn't seem too hard. What if the box has 100 items?
Just A gets 0.
Hmm?
Just A gets 0.
Nope, that doesn't work, okay? Because this doesn't work.
Wait, but I thought A represented the whole box.
It does represent the whole box. But when you refer to A, you're referring to the box. You're not referring to the content of each item in the box. So this does not work, okay? So do not use this notation to say that you're trying to initialize every single item to 0 inside the box.
Is this where you use a placeholder?
Say that one more time.
Is this where you use a placeholder? Like I.
Yes. Okay, so if you are to do this with a box that has 100 items, you really have to spell everything out if you're not using the smarter approach, okay? So you have to basically copy and paste a whole bunch of lines and change the index, so that you have 0 to 99. You go like, okay, phew, finally done after a few minutes. Then I tell you, okay, now we want to make the array having 1,000 items. What are you gonna do? Right? Why would I want to do that? Because now your program has 1,000 lines long, where each line is only going to initialize one item in the box, and there are 1,000 items in the box, okay? And then somebody reminds me and go like, but Tack, didn't you say something about, given the array concept, we can make, better algorithms that are simpler and much more efficient when it comes to expressing the logic? And go like, yeah, we did talk about that, right? What would that look like? So instead of doing this, I'm going to write this code here, and this time it has line numbers so that we can trace, okay? So the first line is I have a variable I, which is not in an array. I is just a normal, regular variable. Okay, it can store a number, and that's all it can do. Line 2 is something that we have seen already. It is I is less than bar a bar. Do. Line 3 is a bracket I gets 0. Line 4 is I gets I plus 1. Line 5 is and while. Okay, so we're going to trace this code next, but before we trace it, we want to understand what each line is doing. Some lines are more cryptic than others. Line 1, do we have any questions about what line 1 is doing? I is just a normal variable. We are changing variable I to 0. Okay, cool. Line 2. Well, we get the I is less than part. We have seen that many times. What about the bar a bar part? What does bar a bar mean again? The number of items in an array. Now, if I don't tell you what is the size of an array, you can't really tell me whether it's true or not. Okay? So when we run this code, we have to make an assumption of the size of the array. But we'll deal with that later. Line 3. Line 3 is kind of a mystery item here, because unlike the picture that I drew earlier, I'm using I as an expression inside a square bracket. But what do you think I as an expression evaluates to? It evaluates to a number, doesn't it? Well, that number in return is how I can identify which item in the box A that I'm trying to initialize to 0. Okay? This is the magic. This is the magic of array. The magic of arrays is we can use an expression, a mathematical expression, so that we can calculate which item in the box do we want to access. Is that okay? So when we run the algorithm, you will find that every time we go to line 3, we are changing a different column in the spreadsheet. Okay? So I'll do the trace next, but I just want to explain the concepts first. Line 4, I gets I plus 1, so that we can move on to the next item in the array. Are we good so far with the pseudocode? Okay. So yes, go ahead.
So AI represents, or like A, so the bracket I, that would represent every index within the box.
Not every. Only the value of I at that time. Remember, I is a regular variable. All it can store is one number at a time. So that means every time we run or execute line 3, it is looking at the value of I and say, okay, I, what is your value? I'm 2. Then A bracket I is now referring to A bracket 2, and we're changing the third item of the array to 0 in that particular iteration. But because I change I at the end of each iteration, so that means for each iteration of the loop, I'm changing a different item in the array to 0. Yes?
So in this case, if we assume that bar is 100,
Uh-huh.
we can assume that I is 99.
I would range, okay, so it depends on where you're talking about. If you're talking about on line 3, then the range of I would go from 0 to 99. But if you're talking about line 2, then the I that we can experience would go from 0 to 100. Because when it gets to 100, 100 is less than 100 is false, and that's how we get out of the loop. But in the trace, we'll see it. Okay, we'll actually trace this with a smaller array. Okay, 100 is a little excessive. Okay. Any other questions about the pseudocode? Nope. Okay. So let's go ahead and run it. Okay. So when we run the pseudocode, we are once again using a trace, which is basically just making use of a spreadsheet. And I'm too lazy to open up a new spreadsheet. So this is the one that I have from a previous class, which has nothing to do with this. All right, so we got comments because we have conditions to evaluate, particularly the one on line 2. We got line number, and we have local variable. We have variable I to take up a column. What about the array? So now we have to kind of make up our minds and say, okay, how many items do we want to store in the array? I think 3 or 4 is fine just to illustrate the concept, because once we get like 100, there's no point to make it that big. So how about just 4? Okay, would everybody be okay with 4 items in the array? Okay, so let's do it that way. So the array is kind of like this, okay? The way I'm going to draw this is I will put an A here, and then I'll put bracket 0 here, bracket 1, bracket 2, bracket 3. And I will even go to the extent of merging those 4 cells into one. In other words, if you just say A, we are referring to columns D, E, F, and G, because we are now referring to the whole box. It's only when you say A bracket 0, then we are referring to just column D. Is that okay? Is everybody comfortable with this notation? Okay. So this time we're referring to an array that only has 4 items. So the precondition is, okay, pretty easy. Everything is unknown. Okay, because I did not say that make an assumption about something. So there's no assumption whatsoever. Every single column starts with unknown. We start with line 1, I gets changed to 0, no big deal. Go to line 2, I is less than bar A bar is, okay, first of all, we know what I is. I has its own column, easy peasy. What about bar A bar? What is bar A bar in this particular case? How many items do we have in array A? 4 items, very good. So we are comparing 0 to 4. 0 is less than 4 is true. We move on to line 3. Now, this is the tricky part. What are we going to do? Okay, so once again, you have to look at this step by step. It's an assignment statement, which means we evaluate the right-hand side and update the left-hand side. Right-hand side, super easy. It's just a constant of 0, no big deal. What about the left-hand side? The left-hand side should always point to a column to update. Now the question is, which column are we referring to? So we look at this and go like, okay, we know that we are trying to deal with array A, okay, because that's the A outside of the bracket, right? Whatever expression is inside the bracket, it can be a simple constant like 2. It can be a simple variable reference like I. But it can also be something that's super duper long, like I times 2 plus 3, the whole thing mod 6, and then multiply that again by 20, and then mod it again with 5, and then square that. It doesn't matter. As long as it gives us a number, and that number turns out to be within the range that we can work with, it's all good. Is that okay? So in this case, what we have inside the square bracket is a relatively simple expression. It's just I. So can someone tell me what is the current value of I? 0, right? So A bracket I is A bracket 0, right? Which column is A bracket 0? Column D, okay? Column D is A bracket 0. So that is the one that we update in this particular iteration of the loop. Are we good so far? Then we move on to the next line on line 4. What does line 4 do?
0 plus 1 is 1.
So which column gets updated to what? Which column gets updated? Column C. What is the new value? 1. Very good. There we go. And now where do we go? We have to go back to line 2 because we are at the end of the loop. We have to go back to the first line of the loop to reevaluate the condition. What is I at this point?
1.
I is 1. Is it still less than bar A bar? Bar A bar is 4. 1 is less than 4 is true. We go to line 3. Line 3 is saying, okay, let's go through this statement again. We are now updating A bracket I to 0. We're updating D to 0 again. No, because what has changed? I has changed. I is now 1. So A bracket I does not refer to A bracket 0 anymore. It is now referring to A bracket 1 because I is 1. Okay? And which column is A bracket 1? Column E. So column E is the one that is now updated to 0. But are you starting to see the magic of utilizing the index and the loop so that we can address and modify a different column for different iterations of the loop? Is that okay? Okay, all right. So we go to line 4, okay, I is incremented again from 1 to 2. Go back to line 2, I is 2, bar A bar is 4, 2 is less than 4 is true. We go to line 3. Okay, I'm not going to spell the entire thing now. Can someone tell me which column is getting updated? Column F. And how do we update it? 0. Very good. You guys are not sounding very enthusiastic, which is good. Because if you feel that this is really boring, that means you're getting it. There will be a lot of moments like this in this semester, trust me. You go like, tag, can we move a little bit faster? That's a good sign because that means you're getting it. Okay, line 4, what does line 4 do? Update I to 3. Very good. Go back to line 2. I is 3. 3 is less than 4 is true. We go to line 3. Which column do we update? G. Very good. And I is now updated from 3 to 4. We go back to line 2. I is less than bar A bar is finally false, right? Then we go to post, and we are done. Are we good so far with this trace? Yeah? Okay. And you can see that I'll repeat it, okay? I said it before, but I'll repeat it. When you look at line 3, when we execute line 3, okay, here, 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 and here, it is changing a different column each time. And that is because variable I is what is really controlling which column we should be updating. Is that good so far? Yes?
It says I is less than A is false.
I is less than bar A bar is false.
How do we know that it's false?
Because, okay, so let's look at row 17. This is why we use a trace method in this class, because I can point to a particular row in the trace, and then we can go back and ask, did tech make a mistake? Okay, because we can now check the condition while we evaluate line 2 on row 17. What is I at this point? What is bar A bar? 4. 4 is less than 4 is true or false? False. That's why it is false. Is that explaining? How do I know that bar A bar is 4? Okay, so it goes back to the meaning of bar A bar. What does it mean when I say bar A bar? How many items are in the array? Right? So how many items do we have in array A? How many columns does A occupy? That's how we know it. Okay? Yep.
So always the bar A bar is always provided in the question mark.
So bar A bar is assumed that you can compute it at using some way you can figure it out. So that's a very tricky question. Is in a real programming language, how do we know how many items are in an array? So that's a very good question. So I'll address that question once I hear the other question first. Yep.
For the 0, 1, 2, 3, can we call them item, not column?
Because this is a spreadsheet, and the way we designate a column in a spreadsheet is a column.
I mean, when they use update, can we call the item got update the new value?
That's a very good question. Okay. So when we refer to, okay, so I'll just pick one particular one. So when we refer to this thing here, okay, regardless of which row it's in, it has got 2 names. I can refer to this thing as something in column F. I can also refer to the same thing as the item 2 of A, right? It is the item that has an index of 2 inside array A. Is that okay? So I can call this column F. I can also call this A bracket 2. The question is, what is the difference? What is the significance? In this class, when we use the columns, okay, columns C, D, E, F, and so on, those are corresponding to memory locations of a computer. Okay? Now, I don't want to refer to memory locations because it is a little bit too early to introduce that concept. But for those of you who want to kind of understand that part, each column is a memory location, not counting columns A and B because those are basically just things for me to use to keep track of the execution of the program. Okay? But all of the other columns, column C, D, E, F, G, are memory locations. So when I refer to column F, I'm referring to a particular location in the memory of a computer and say, this is how we update that location. Is that okay? So it's more or less from a hardware perspective. Okay? The other perspective is, but this is also A bracket 2. And you will be right. A bracket 2 is how we look at that location from the perspective of a program. Okay? So we call this aliasing. Okay? There are two ways or multiple ways to refer to the same thing. We can refer to it by memory location, which is quote unquote column F. We can also refer to this as a programming concept, which is item 2 of array A. So that's a good question. So getting back to your original question is, well, in a programming language, how do we know how many items are in a particular array? If you're working with a scripting language like JavaScript, Python, PHP, Perl, Ruby, and so on and so forth, it's pretty easy. Okay? In JavaScript, you just have to say the name of the array dot length. Okay? They don't use the bar notation, but there's a pretty easy way to do it. Syntactically, you just say a dot length, and that will tell you the number of items in array A. Okay? And other languages like PHP or Perl has similar but slightly different way to do it. The problem is C and C++. Okay? In C and C++, there is no way to tell how long an array is. It has to be represented explicitly by another variable. So I would have to give you an extra variable, let's say n, and have that thing to have a pre-value of 4 to basically say, well, this is the actual size of the array. It has 4 elements. Okay? But that question kind of leads to yet another question, which is, in this particular case, if the program, for whatever reason, terminates incorrectly, let's say instead of less than, I have less than or equal to. Okay? Now, if I have less than or equal to, then the last time I execute line 3, I is going to be 4, right? So now the question is, if the code is calling for item 4 of an array that only has 4 items, what is the computer going to do? Do you guys see what the problem is? I don't really have a bracket 4 taking up location, column H in the spreadsheet because it does not exist. I have an array with only 4 items. But if the code is attempting to access item 4 of that array, what is going to happen? Okay? So what do you think? It's a trick question, by the way, so it's okay not to give me the right answer, but I do want you guys to kind of think about it and just give me your guess. Does anyone want to try? Yes, go ahead, give it a try. Does it create a new item, right? Does it start to use a location and say, okay, now you have 4 items in the array? That answer is correct, okay? But only for certain programming languages. What about the other approach? What about something else that it might do? Yes? It might say error. Okay, that is correct as well. Okay, some programming language will actually do that. There's one last one, okay? So what you said is what a scripting language like JavaScript would do. What you said is the second answer is what Visual Basic would do. There was another hand. Yes, go ahead. Huh? It will just pretend that column H is A bracket 4, even though it is not. Okay? That would be the answer for C and C++. Okay? So depending on which programming language you are using, that the answer to that question of I'm trying to access an array out of range, the answer would be different. In C and C++, that's the worst possible way to handle this situation, okay? Which is basically just saying, really have no idea, okay? The compiler or the computer has no idea of how long the array really is or how many items are in the array. So if you say A bracket 4, I'll just I know where it starts, okay? I know array A starts with column D. So if you say, oh, change A bracket 4 to 0, I'll just be counting. 0, 1, 2, 3, 4. I'm going to update column H. But column H is not allocated to the array. It might be allocated to something else. So that statement, A bracket 4 equals, gets 0, is going to clobber something unintentionally. It's going to corrupt something unintentionally. You cannot. You have to code carefully to make sure that that does not happen, because C and C++ has no built-in mechanism to prevent that from happening. Yes?
So you said in C++, you have a different variable as an n that tells you how long the array is?
No. Okay, how should I put it? You will need a different mechanism. Somebody has to tell you how long an array is.
Okay, but how would it come into a trace?
It becomes really difficult for us to trace. Basically, you have to assume that somebody is giving you a number, a separate number, that indicates the number of items of the array. Yep. So C and C++ is kind of tricky, from the perspective of how it's going to look like in a trace. Okay. So you have some exposure now to the various bad conditions that can happen when you try to access an array out of bound. The visual basic method is the best. The program just stops working because it will give you a complaint, and it will even say on line blah blah blah, okay, you're trying to access an array out of bound, and then it will just exit the whole app, which is good because instead of doing the wrong thing or something that is potentially wrong, it just says, I don't know how to deal with this. Okay, here's the line number. Somebody has to figure this out. That's the best approach. But most of you are moving on to cisp300, which means you will probably encounter the situation that I described earlier a few times. Basically it's called accessing an array out of bound. Okay, and by the way, that is also how exploits happen. Has anyone heard of stack overflow exploit or heap overflow exploit? Okay, that is what's happening. Okay, those are exploiting careless programming practice, so that a intentionally malformed something can overwrite certain memory locations strategically, so that a hacker would gain control over a computer. Okay, so this is all good stuff. Okay, if you don't understand what I'm talking about, what Stack Overflow exploit means and whatnot, it's okay. Okay, this is not the right class to talk about it. But if you just remember that term and relate it to accessing an array out of bound, that's good. Okay, because by the time you move on to cisp300 and also 310, if you can retain that piece of information, it will help you. Okay? Are we good so far? So in this class, we kind of have to assume that we are not accessing an array out of bound. We just have to be super careful about that. Any questions? No questions? Okay. So if there are no questions, we're going to go back to the notes and see what else is here. Okay. Listing 4. I think that looks awfully familiar. Because we just talked about it. And you can see that there's written text explanation of every single line of that code. So, in addition to being here in the lecture, I strongly recommend that you guys read ahead of me. Did anyone read ahead of me okay, did it help? Did you feel awfully bored in class? Yeah, good. Because if you had read ahead of me, this is all old stuff. It's like, yeah, I kind of know that already. Okay, very good. So algorithm 4, okay, you don't have to trace it because I just did it, okay? So now we move on to section 5, which is searching for a particular value in an array, okay? So I give you an array. You can assume that we know the number of items in the array correctly. And I say, well, does any one of these items, does anyone equal to this particular value? Okay, I just need a yes or no. Okay, yes, yeah, the value that you're looking for is somewhere in the array, or no, it is not in the array. So how would we do that? Okay, so what we'll do is we'll try to derive the code step by step. And the other thing is we also want to assume the array may not be sorted. Okay, so that's an assumption. All right, so there we go. All right. So the first thing we need to do is to give ourselves an example so that we can do it by hand first and then see if by doing it by hand, see if we can derive the logic of using an algorithm to solve the problem. Okay? So I'll first give you a really bad example of, okay, let's try to solve this by hand. Okay? So let's say the array has 3 elements. Okay? A bracket 3 is known. Don't ask me why, but this is the value that we store in it. It's 36. A bracket 1 has a value of 12 stored in it. And A bracket 2 has a value of 47 stored in it. Okay? And I say k is representing what value we are searching for. And k is given to you as 20 in this case. So the question is 20 in one of the 3 items in this array? And all of you will say, no, it's not. Okay, that's a stupid question to ask. It's stupid because you can eyeball this and figure out right away and say, nope, 20 is not in it. Which also means it is a very bad example when it comes to, can we utilize this example to help us derive the algorithm? Because if this is simple enough that you can quote unquote just eyeball and know the answer, you're not going through a procedural step-by-step method to find the value. Is that okay? So not a very good approach. So what is a good approach then? Rand between is good. Okay, so it's a random number between, let's say, 1 to 1,000. Okay, and I make a bunch of these. Okay, it doesn't really have to be too excessive, but it needs to be excessive enough to make a point. So I'll just make 60 of these. Okay. So there are 60 of these right here. And once again, I'm asking, is 20 one of those 60 items, which keeps changing all the time? Now you cannot just eyeball, right? Now you have to actually scan it and go like, well, why would tech want me to do something like this? This is really tedious. I have to scan. No, 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 right? But that's what the program needs to do. Because remember, the program, in a comparison, how many things can you compare with one single comparison? Only 2 items, right? The key is 1 item on one side. What do you think is going to be on the other side? The value of one particular item in the array. So your eyeball mechanism doesn't work because your eyeball mechanism is quote unquote comparing multiple items all at the same time. So now you basically have to use a ruler. Okay, I can't really emulate. I can in fact emulate a ruler in this case. Okay, I'm going to use this as a ruler. Forget about the text on this thing, okay? It's irrelevant to this class. So now I use a ruler and go like, is that 20? No. Is that 20? No. Is that 20? No. Is that 20? No. 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 And so on, right? First of all, does this give you a rough idea of what the algorithm, what kind of control structure the algorithm needs? Is it going to be like just a sequence? Is it going to be a conditional statement? Is it going to be a loop? A loop, okay. What gave that away? It's very repetitive, doesn't it? Okay. Anything that is repetitive is like dup, 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 dup. Okay, that spells like a loop to me. Okay. It doesn't mean that you cannot use a very long, complex, and unnecessary conditional statement to do it. You can do this whole thing using a conditional statement, a nested conditional statement that has 59 levels of nesting. I'll spell out the first few levels and then you can complete the rest, okay? The first level, if a bracket 0 equals k, then else. If a bracket 0 equals a bracket 1 equals k, then else. If a bracket 2 equals k, then else. If a bracket 3 equals a k, then. Would you want to do that, use that approach? No, because the moment I say, oh, guess what? Instead of 60 items, now we have 600. That would not be a fun program to work on, right? So, when I move the ruler from one row to the next, what do you think is being changed? I'm changing which row I'm referring to, right? Each row, in this case, is representing an element in the array. In fact, if you look at the row number, that's just one added to what the index should be, right? So what is it telling you about what we need to do in each iteration of that loop?
Change the row you're on, change the element that you're referring to.
Change the variable that controls which element we're looking at by 1. Exactly, we increment something, right? We move on to the next row. Okay, very good. When do we get out of the loop? In other words, I keep doing it like this. I say, is that k? No. And then move on. Is that k? No, 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 no. And I keep going like this. No, 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 no. And by the time my ruler gets to this point, is that 20? No. Is that 20? No. Oh, we need to get out. Why? There are no more items. Okay. So it seems to me that there are two reasons to get out of this loop, right? One reason is I just found it. The second reason is what? There are no more items to look at. Okay? So what we'll do, we got 5 minutes, and I think we got just enough time to get this started. Okay? So we have two loops here. We have one loop. We have loop and loop. We don't know what kind of a loop. In other words, it could be a repeat until, could be a while do. We don't quite know which one. But we can specify when to exit. So I'll just say exit when k is found. Or what is the other reason to get out?
There's no more items.
No more items, okay? There are no more items to examine. Okay. Someone look at this pseudocode and go like, that's not even pseudocode. This is just a bunch of mumbo jumbo. Well, you're right. But now we can refine it, okay? We kind of know what we need to do for each iteration, right? Something that looks like I gets I plus 1. Yes? Okay. So can I refine this particular phrase? What does it mean when k is found? What does it mean? I want to make use of I. Go ahead.
K equals I.
I equals to 20.
K equals what? A bracket I. Very good. Okay. I think you got the idea, just didn't specify the syntax. Okay? That makes sense, right? I had just found an element in array A where the value equals to the key, which is what I'm looking for. That's a good reason to get out of the loop. I just found it. Okay, cool. Okay, the second one is there are no more items to examine. Now, this one is a little bit tricky because we have to look at this one with the assumption that we start from the beginning of the array and then we move to the end of the array. So the question is, how do I know that we are at the end and there are no more items to examine anymore? Yeah.
I'm gonna guess here, but
Go ahead.
A bracket I is larger than bar A bar.
Okay, I like a part of it. I like this part. But what do we put on the other side? Just I. Okay, just I, not A bracket I. Okay, now this is important because all we want to say is, because I is the variable controlling or trying to indicate which item we will be looking at in the next iteration. So when I is greater than or equal to bar A bar, it means I is invalid already. There are no more items to look at. Okay, so we're almost done. We got 2 minutes left. So the next question is, okay, what kind of a loop should we use here? Okay, remember, while loops are the majority. Okay, so unless you have a good reason, do not use a repeat until, use a while loop. So I'm going to use a while loop here. But when you use a while loop, the condition that you need to specify is the opposite or the negation of the exit condition. So that's going to be as long as k does not equal to a bracket I and I is less than bar a bar. Okay. Now I'm going to keep this order here, which is actually problematic, but we'll talk about why it is problematic in the next class. In today's class, we'll just go ahead and finish the logic here. How should I initialize I? We got more than 1 minute left, so just give me that 1 more minute. I get 0, yes, because 0 is the index of the first item in the array. So if you look at this code here, if the first item has the value that I'm looking for, I won't even execute I gets I plus 1, because the condition of the loop can check and go like, oh, we just found what we're looking for. Time to get out of the loop. I don't even need to increment I once in that case. So this is why a pre-checking loop makes sense in this case, because what if the first item is the one that I'm looking for? Then we don't need to get into the body of the loop. So are we good? I'll let you guys go. You know, we have less than 1 minute left, but I'll go like, that's quite good.